Good day, folks. Welcome to Price Mind Academy, where we bring brilliance to every lesson. Let's look at question 11 for May, June 2024 question paper. Those was written by those who were writing. Okay. Okay. So it tells me that two events, A and B, are such that probability of A is 0,4, probability of A or B it is 0,552, and A and B are mutually exclusive. Okay. What does a mutually exclusive mean? Remember, mutually exclusive tells me that probability of A and B it is equal to 0. So how can I find probability of B? I'm just going to use the formula that says probability of A or B, probability of A or B, it is equal to probability of A plus probability of B minus 0. Remember the formula, it says minus probability of A and B, but since well it is 0, I can just write it like this. What is probability of A or B? 0,52. Probability of A, 0,4. Plus probability of B, just easy peasy. Probability of B is just 0,12. Just easy, guys. Just easy, guys. Just need to understand your theory. The items that a learner bought at the tuck shop were recorded over a period of time. The probability of learner buying a sandwich, chocolate, a juice are shown in the diagram. Blah, 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 blah. What is the probability? Okay, let's now find the sample space. The sample space is always 1, guys, I think. Let's check. Yeah, since if it is written like decimal like this, there are high chances, like 99.9999, that it is 1. Let's add them and see how much you get. Okay. 0.20 plus 0.04. Yo, wait. Plus 0.09. I can't even remember. Okay, 0.04, 0.03, 0.01, 0.20, 0.04, 0.09. Okay. Plus 0.02. Guys, I get something like, yeah, it is 0.43. If this is 0.43, and then so it means this one might be 0.57. Okay, let's move on, guys. But the total here, which are appealing. Okay, what is the probability that the learner what sandwich? Did they say the probability? Okay, what's happening, manch? What is the probability that the learner will buy a sandwich? Where's sandwich, guys? Sandwich. So the probability, if you're given in decimal, it is already in probability. You just need to add them, guys. Probability that is a sandwich is going to be this plus this, which is 0,1, this plus this, which is 0,16. That's the answer, guys. Can you see they're saying the probabilities of the learners, they have already been given to you. So you don't need to divide by whatever. You are given the probabilities already. So calculate the probability that the learner will buy at least 2 of the 3. Guys, at least 2. It's here. At least chocolate and juice, at least juice and sandwich, at least chocolate and sandwich, or at least 3. At least 2 means the minimum that you can have. It's either you have 2 or more, not less than that. So when I know, no. So it's going to be everything that is 2 or more. So when I do my mathematics, it's going to be 0,03 plus 0,04 plus 0, which is 0,08, and then which is 0,10. You just add them, guys. You just add, guys. You just add, guys. Do your mathematics, add. Calculate the probability that the learner will not buy any of the 3. Any of the 3 is 1 minus these 3, all of them. Okay, it's 1 minus all of them, and all of them it is 0,43, guys. And I've already written it out here. In neither 0,57. Okay, just easy. Will not buy any of the 3. So it means that learner does not like anything. Let's move on to the beautiful one. It says 7 guitar players, each with a different name, participate in a concert. Right? In how many different ways can the names of the guitar be listed, one below the other in the program. So how many guitars do we have? We have 7. So they can sit in 7 factorial ways, because it can either be wena, 7 of them. So the first question, 7 factorial ways, which is 40. 7 factorial ways, it is equal to what? 50/40. So they can sit in 7 factorial ways. But now they say after the performance, the guitar players wait backstage. There is a bench with only room for 4 to sit. Okay. Sorry. What is the probability that the 4 guitar players will be sitting in alphabetical order from left to right? In alphabetical order from left to right. It's just just a little bit. They say to me, what is the probability? So what will be the probability that 4 guitar players will sit in the alphabetical order from left to right? From left to right. So the probability will now be either from left to right, it's going to be 7 multiplied by, because only fallen people can sit. So 7 times 6 times 5 times 4. So only these people can sit down. Only these people can do what? Can sit down, which is how much? Uh, Let me confirm. 7 times 6 times 5 times 4. It's how much? 840. Bon. Not 840, guys. So, yeah, 840. 840. So these are how these people can sit. But now they say, calcu, huh? Calcu, okay, what will be the probability that the 4 guitar players will be sitting in alphabetical order from left to right? So the total people that can sit, there are 840. Okay, I want you to take note of this. The probability that they will sitting in alphabetical order. Okay, if I'm having this 1, 2, 3, 4, and there are only 7 people, there is only one chance that 4 of them are going to sit in alphabetical order, because it's going to be Anna, Bena, Bella, Chantel, and Dumisan. So there's only one way in which these people can sit. Okay, out of possible what? So it's going to be, there is only one way that these people can sit in alphabetical order. Because if I were to put someone here, maybe Emma, this is not alphabetical order. So there is only one way that these people can sit in alphabetical order. So they can only be one way, but now divide by their seating arrangement, which was 6 times 7, 7 times 6 times 5 times 4. So this is that. So it's going to be 1 divided by 840, which is whatever. So yeah, this one was a little not beautiful, but yeah. Okay, so that's that. And then I move on. It says, during the performance, the 7 guitar players sit in a line sit in a line on stage. 4 guitar players are females and 3 are males. It says, in how many different ways can they be seated if the males may not sit next to each other? May not. If the males may not sit next to each other. On this type of question, what we do, we say, let's make them sit together, and then we say 1 minus the probability that they do not sit together. So let's say we have what? We have 1, 2, 3, 4, 5, 6, 7. Okay. And I'm told that males may not sit next to each other. So let me make males sit next to each other. So it's going to be male 1, male 2, male 3, and then female 1, female 2, female 3, female 4. But now, if these are sitting next to each other, it means they will form a unit like this. If they sit next to each other, they will form a unit like that. And after forming a unit, we consider them as one. But now, since well, there are three of them inside, we're going to say 3 factorial. Why 3 factorial? Because they can rearrange themselves in whatever manner. It can either be male 1, male 2, like this, or male 3, male 2, male 1. So there are 3 different combinations that they can do. Okay. So we take them as a combination and say, now we are having them like this. So this is now the combination of male, okay? Multiply by any females thereof. So on this one, how many ways can they sit? So can you see it's going to be 1, 2, 3, 4, 5. So there are 5 factorial ways in these people can sit. 5 factorial ways. Whether males, female, this, and this. Okay, there are 5 factorial ways in which they can sit. Okay, where they can start with a male, they can start with a female one, as long as they are sitting next to each other, right? So, but we need to multiply also by what? By them, how they can be arranged. The 3 factorial that I said you should write at the top, 3 factorial. And then it gives me something like, uh, something like, what do they want? How many different ways? So 5 factorial. So this is probability that they will sit together. The probability that they will not sit together will be the total minus sit together. What is the total? Total, it is 7 factorial ways in which they can sit, minus sit together, it is 5 factorial multiplied by 3 factorial. Okay. Let me read. During the world, in how many different ways can they be seated if the males may not sit next to okay? So it's going to be 7 factorial minus that they sit together. Uh, this is the same as saying probability of not A. Remember, how do you find probability of not A? It is 1 minus probability of A. So now we are wanting the not. So it's going to be the total minus the happening. Okay. I get something like 43 now. Okay. I get something like 43 20. But okay, what was I looking for? Let me come back here. If males may not sit next to each other, right? So just give me a moment to see the question. Okay. Or another thing that you can do, let me see here. 5 multiplied by in how many different ways can they be seated if males may not sit next to each other? So if males not sit next to each other, that's gonna be okay. Let's try to do it randomly and see if it gives us the same outcome. It's gonna be a long process, but we can try that. Ways in which now they can sit. Okay. So it can be male, female, male, female, male, female, female, female. 1, 2, 3, 4, 5, 6, 7. Okay. So you can do the combinations here, like those combinations. you can make those combinations and see how many combinations are there. And then you'll see that, okay, male 1, male 2, male 3, male 1, female 2, female 3, female 4. You'll see that this is the first one, and then you can say, so here, they can sit, males can sit in 3 factorial ways in which they can be arranged. What do I mean by that? They can either be coming here, this one, and then this one remains here. Like, let me make another example. It can either be male, or we can alternate among women. Write them exactly as they are, but alternate among women. Say female 2, male 2, female 3, male 3, female 4, blah. You see, and then female 1. This is multiplied by 4 factorial ways. You can go all the way down there and see thereof, guys. What you will get. What you will get is that there are 10 combinations of doing this. There are now 10 combinations of doing this, and then you just multiply by 10. Let me see, 3 factorial. Man, 3 factorial, multiply by 4 factorial, multiply by 10, get something like 1440. Come on. You get 1440 there, guys. So yeah, you can do it manually, or you can try to do it either way. But I like to do it in this manner, where I take, during a performance, the 7 guitars sit in a line on a stage. 4 guitar players are females and 3 are males. In how many different ways can they be seated if males may not sit next to each other? Okay, may not sit next to each other. I like to say, okay, let's see if they sit next to each other, what we will get. Okay, and then my subtract the total, which is what I did initially, but the answer seems to be different. So let me see. If they sit together, male 1, male 2, male 3, and then there are women here who are sitting nicely in 4 factorial ways. Okay, they're not necessarily together. So it's just female 1, female 2, female 3, female 4. And then we can form, these one can come, like they can be in this combination, where I start with female 1 and then have that group female 2, female 3, female 4. And then or have female 1, female 2, that group female 3, female 4, or that group there, and then female 4 here, or female 1, female 2, female 3, female 4, and then have them here. So they can either be how many options? So 1, 2, 3, 4, 5. Though there are 5 ways that they can sit like that. Multiply by the factorial inside here is, remember, it is 3. So it is 3 for all. So it's going to be 3 factorial for those boys sitting together in that group. Multiply by, how can I rearrange them? 1, 2, 3, 4, 5. So there are 5 factorial ways. Dim probability is going to be the death of us. And then yeah, so, and then you can say 7 factorial. This is the probability that they sit together. Sit together is going to be, there are 5 ways that I can rearrange them. Multiply by 3 factorial ways of the boys here. Multiply by 5 factorial ways in which I can rearrange them. Like it's going to be 5, 4, 3, 2, 1 again, because I cannot repeat people. 5 factorial, which is something like 5 times 3 factorial times 5 factorial, and then it gives me 3, 600, and then probability that they're not together is going to be the total, which is 7 factorial minus 3, 600, which now gives me 14, 14 what? 1400 or 1440. Let me see. 7 factorial minus 3, 600, 1440. So you can get 1440, guys. You can do however you want to do it, but yeah, the best option, I like to do them, let them sit together, and then find the probability that they do not sit together. Okay, yeah, instead of doing this manual way. So yeah, that's all, guys, from me for the May June 2024 question paper. Hopefully you enjoyed it and learned something.